You can just do requests, but not store the content. So we might have some mechanism between you and the caller that will intercept the data and store it. So that's what we needed. So we want to use any HTTP clients basically as callers because we want to be able to develop maybe a small, like quick and dirty caller to call YouTube that will be like obsolete in 2 weeks, and that should be easy. We want to be able to use full-blown browsers as callers, for example, Firefox for like manually crawling websites when we don't have the time to develop a caller, but want to do it like fast. I'm thinking about specific events when you need to archive, for example, the Olympics website, and you don't have full months to develop a caller, but some sites will disappear, and you need to call it now. Use Firefox. I said, and you don't want to duplicate the archive writing code for many reasons. First, it's long, it's hard, and if you do it wrong, you will have wrong archive files, so you don't want to have that. A bonus to the approach that we have is using a proxy, HTTP proxy is standard. Every HTTP client, almost any HTTP client, has the possibility to have a proxy. So it's by itself already a standard. We want to isolate the part of the process where we write archive files because it's cleaner for the workflow to write archive files in one place. It can be safer too. It can be machines that are separate from the whole calling infrastructure. It can be like exposed to, I don't know, crashes, viruses maybe, or like the web can be like difficult to sometimes prevent things from crashing, so you want to isolate the part where you're writing files that you want to keep safe. Being able to detach the crawler from the archive writing code in that way makes you able to write the crawler and the archive writing code in different languages. So you can have a crawler within in JavaScript and write your archive with Java, and it will be just built-in easy. And you virtualize archive writing, which means you can have like a data center where you write your archive, another one when you do your crawler, for example, without having to worry about all the wiring. It's just the writers will connect to the proxy and do what they have to do. You don't have to worry about that. So we thought it was easy because we were doing it already, but maybe it's not that way. So how does it work? It's just an HTTP proxy, basically. So you have as many clients as you want going through the HTTP proxy and then to the web. And what the proxy does is when it receives answer from the web, it splits the data into duplicates data. One piece is sent back to the original requester, to the caller, and one piece is put in a buffer, and it waits for a writer to connect. So it's a network protocol, and a writer connects and asks for parts, and receives them, and then does whatever he wants with it. So you can discard them, or write them to an archive file, whatever the format. So to make things easier to understand, there is like a dashboard interface for you to watch what's happening inside the proxy. So you can see how many requests are being sent out of the proxy, the data flows, the number of requests per second, the number of megabytes per second, and you can see the buffers fill up, because if you don't have any writers connected to the proxy, it will store everything in memory. And if the memory is exhausted, then on disk, you can see here, here's the memory filling up because the writer is connected. Here's the requests in megabytes, and here a number of requests per second. You can just run the video actually. here you can see the dashboard refreshing every second, and the buffers filling up and the request going through the proxy. And at some point, I will connect a writer to the proxy, and you will see all the data that has been collected, which is here, being drained back to the writers and being stored in WAR files. So basically, during this, I'm browsing the web with Firefox and the proxy setup in Firefox, and it stores everything that I'm visiting. Approximately 150 megabytes, I think, and the light green part is the part that is being stored on disk, because it's a file that it detects files that are bigger than 5 megabytes, stores them on disk. Here you can see the writer has been connected, and the buffers start to empty. So, works as expected. So you have a list. You can have many writers connected to the proxy and generating the archive file at the same time. If the flow is too big, if you have too many data at the same time, having many writers will spread the writing process on many machines. So that's one of the interesting points is if you have a flow of data that is too heavy for one machine to write, you can have a writer on 2 separate machines, and it will spread the load of writing files. So how does the writer plugin work? For the moment, we have 3 writers. The WARC writers, which has been developed by our friends at NetArchive. A DAP writer, which is our own format, which we use internally. A log writer, which is for testing, so it generates only a list of the URLs that have been accessed, but with no data. It discards the data. And we're currently working on building an ARC writer, because people at Internet Memory Foundation in France who are testing said they would love to have one, because they use ARC for the archiving. And if other members are interested in the ARC writer, maybe they should speak up and maybe join in the effort. So, writing plugins. If you want to have a writer for a specific need, I'm thinking maybe about the logs project. If you want to store the data in a different format, if you don't use WARC or ARC or anything that we use, it's actually pretty easy to develop your own writer. I've put generic code for the writer, which is like a jar on Maven. And all the details here on how to access the library. And all you have to do is inherit the default writer class and overload a method which is called onContent. That's basically it. And you receive an input stream of the data for each URL that you are archiving. So I think it's pretty easy. And depending on how complex the format is that you're writing to, I think it's a pretty short task. We've had feedback already on what the first people who used proxy were thinking, and first what they were trying to do. One of the big issues is, as I said at the beginning, is dynamically loaded resources, which Ravnikar misses. One particular example was resources that are being loaded by Flash applets, and Ravnikar cannot go into the applet and extract the URLs. For that it works, but then there will be a problem at consultation, because it's still a problem for Wayback, for example, to replace those URLs in the Flash. We at INA use a proxy-based consultation, which solves the problem. So we love proxies, as you can see. They solve a lot of problems actually, because they make everything transparent to the browser, so you don't have to mess up with prefixing URLs with the consultation server URL, so it makes things easier. But still, at least for extraction and storage it works. Then consultation is another issue. Complementary calls and QA. Internet Memory Foundation has done that to test going through WhatsApp archives and see if some requests are being responded by wayback as 404, and then sending those through the proxy, running proxy, and archiving what they have missed. So they have a complementary call and filling up the holes. Human-based polling, of course, like I said before, and some members have tried to do YouTube polling. I think that was you, with Internet Explorer 10, if I remember right. And,
different browsers actually. There are a whole bunch of problems actually around different browsers and different versions of Flash plugin.
Yeah.
Some of them do like chunk requests, which means that in your WAV file you will have like 100 chunks of a video file instead of one big file, which definitely complicates the replay.
Yeah.
So but
so it's a mix-up problem between harvesting and consultation, because if you manage to have the whole video file as one URL, the URL is still like one shot, because it's being generated on the fly and contains a timestamp, so you can do nothing with it at consultation for now. So there might be new other tricks to develop for consultation, but on the harvesting perspective, what I see is the LiveArchivingProxy might not be the solution to it. It can be a part of the solution, but I think there need to be development effort into like specialized callers for YouTube. We at INA develop such callers and might take the time to share them with you at some point if we can make them like manageably shareable, which is always time consuming. But I think the LiveArchivingProxy as itself is only a part of the solution. The whole solution comes in developing new callers, as I said before, that are adapted to a sort of content. Issues that have been had, no HTTPS. Of course, that was one of the issues that we raised last year already, and we didn't have time in the schedule to fit in the development effort to handle HTTPS. We will probably add the support for HTTPS by, I don't know, maybe the end of the year. We find the time frame to do it. But it's definitely planned and has been asked for, and doable, I think. So as we just said, dynamic URLs are a problem, but I think it's more an issue of consultation than of harvesting, except when it's like chunks, or it's clearly a harvesting problem, but maybe there are tricks to do in the crawler, which could detect that it's on YouTube and this is a YouTube video and this is the ID of the video, and add some metadata to the request that the proxy can intercept and use to as a trick and change the URL, but I'm against changing the URLs, but maybe just adding some metadata so that the video can be indexed and refound afterwards at consultation time. Other problem, JavaScript enabled for browsers. You need to have, of course, your crawler JavaScript enabled. The lab will not solve this for you if you don't have the right crawler. You can, of course, crawl maybe using Heritrix through the lab. That would be possible, but the lab will not do the request that Heritrix does not do, so it doesn't solve the problem. It just makes solving the problem easier. And for the moment, as we just said, there are no free open crawlers that are for YouTube or other streaming media websites, and we develop some internally and might share them with you. We have some for Dailymotion, YouTube, SoundCloud, Vimeo, and that's all. And those are tricky. But I think most of the members have expressed this year and last year too the need to have some, and that might be compatible with an approach to the lab, so that may be complementary. So feature request, HTTPS of course. You, I think, have requested to add the client IP to the metadata because it's requested by the work format, I think. Server IP to metadata was asked too, but it's difficult because it's hard for the client to know the IP, which could be another proxy in the chain. We would do that if you ask us to, but we think that might be misleading because it can just be an internal IP address, and storing those might just be a waste of resource in the work because who knows what these IPs are. An option to discard content when no writer is online, because yeah, as you've seen, when no writer is connected, the data fills up the buffers in the lab, so that can be problematic. So maybe in some cases, so we might add that. I think we will add that option. And the thing that was asked also is to have like more complex writers, maybe a web interface for the writer to choose maybe to write files to different work files depending on some criteria that can be determined. So I think the idea that we had was during the communication between the lab and the writer, they could exchange an address, an URL that will be exposed in the dashboard for the lab that could lead to the web interface to the writer. Then have the writer expose its own web interface and do all the work internally without having too much complicated communication between the writer and the lab, because we want to keep this part simple and rather like standard. Arc writer was asked too. So yeah, collecting two different work files, the criteria were different crawlers would be able to archive through the same lab, but two different work files. So those are requests for the writer. So I don't know if you have more time actually to invest in adding features to the writer for this, or if you would like us to intervene. But since we don't use the work format,
yeah, let's discuss.
Okay.
Afterwards.
And yeah, adding a web interface for the writer, it's, I think it's a big chunk, but could be useful. So that's it for the presentation of the lab, and I'm hoping to get questions and maybe comments on how we're doing things. And just so you don't leave right now, we will do a demo after the discussion, depending on how much time we've left. I think we'll have time. So a small demo of a running lab, which I have, you have on your machine. I'm accessing right now the interface. So, come on. That's Chrome, let me. Okay. So this is a live running LiveArchivingProxy, which is running on Matt's machine. I'm accessing the dashboard from mine. And one of you maybe could like use his IP as proxy and see that we will be able to archive through the proxy, then run the generated work with a way back.
Do you want to do that now or at the end?
Well, maybe while we discuss, some of you might like just use that IP address as a proxy.
So basically what I've got set up here is I've got my my XP machine, and I've got a virtual machine running on that with a 64-bit version of Linux, which supports basically the lab and the lab writer. And then that's kind of bridged through the wireless to give an external IP address. So I'm not thinking what could possibly go wrong. And afterwards, we've also got a version of the Wayback installed on that, so we should be able to actually look at the archive web pages after we've archived them. So, do you want to do that now? Okay. So basically, I'm actually connected to that at the moment, so if I send through a request, you should see, there we go, there's something popping up at the bottom. But if you, take your browser and change the proxy to that address there, and then browse a website, that should then...
So this one.
Yeah.
And we can see requests, so someone's...
I'm watching YouTube.
Okay. So if you're watching YouTube, yeah, you're filling up the buffers. I see that.
And if you just want to make a note which domains, which websites you're actually using, because we need to find that in the Wayback Machine afterwards.
So first line is request per second. Second is byte or megabyte per second, depending. So here we have like spikes at 2.5 megabytes per second, 40 requests per second in spikes, and we have 30 megabytes in the buffer right
I'm
now.
watching the IPC video on the IPC website.
Okay. I hope it's not HTTPS, because if it's HTTPS, it will be discarded by the proxy.
I don't think so. It's not the main page.
Should I launch the writer now? Or go to the login?
Well, if you launch the writer, you will see the buffers
Okay.
empty. So right now, no writer is detected, and at some point it will like detect the connection of the writer, and we will see the buffers empty up. There it is. It goes down. Whoops.
Oh, I just paused the video. Should I keep it going?
Yes.
Oh,
yes.
okay.
Oh, yeah, you can.
I've just seen it before.
Meanwhile, maybe you can launch a description, and maybe some of you have questions.
Just wanted to clear, the proxy itself and the writers are separate processes, basically.
Yes, it's
And
two
they-
different pieces of
And
software.
they communicate over.
We have developed a protocol internally, so we have written to make things easier for everybody, so people don't have to write the whole socket protocol by themselves. The proxy is actually a Perl software that we have compiled and packaged as a binary executable with a Perl archive, PAR, which is like pretty well known, works well. So it's one binary file that you launch. And the writer is a Java jar, a runnable jar. So it's two different pieces of software. And the writer actually contains, as a dependency, our generic writer, which contains all the dirty socket work to communicate with the proxy. So the whole thing you have to do is, like I showed before, is implement the class, and you receive an input stream. You don't have to worry about communication with the lab.
Yes. What happens when you enter the HTTPS address?
So if you
pass through or it block?
I think you will receive a refuse when you send an HTTPS connection to a proxy like this. The proxy receives a connect request with the address of the SSL server. I think it will just refuse that connection, close it. So your browser will see something like could not reach the host. Depending how you set the proxy up, because you can also set different proxy for HTTP and HTTPS. That's the case for Firefox. So either the connection is refused, or if you don't set a proxy for HTTPS, it will just go through without switching.
So if I use the settings of proxy for HTTPS protocol, it will block.
Yes.
Okay.
We refuse the connection, and you will have like an error. The browser will react as if there was no network access.
Okay.
This is twitter.com.
Exactly. Twitter.com that uses HTTPS only, so
Yeah.
it's a very good example. Questions? So I think the next step would be to compile like a user guide. We have started to compile a user guide for other people to use the proxy, but I'm waiting for more feedbacks from the first people who wanted to test the proxy, and maybe we'll add some of the feature requests before releasing the code. But for now, if you are wanting to test the proxy right now, you can. You can download from this address, which is showing up. Yes, it is. The lab binaries, the writer, different writers actually, a small user guide that I've put together to help you start. And that's it. And if you want to develop your own writer, there is a link to our Maven repository with the generic writer code. Yes.
What about the source code for the lab itself?
For the lab itself, it's currently on our internal SVN server. We're planning on releasing it maybe on Git. We're not sure. It's Perl code, so well. Maybe we'll release it on Git directly, yeah. I think that's a plan.
Because not everybody will have a Linux 64-bit.
So if there are requests of us compiling it for different platforms, might take them into account depending on, maybe not for Windows, but...
I think mostly probably Linux, but I know for us, although this is going to change soon, we still run quite a lot of very...
32, so we might... Do we have?
Well, we can make this. I can make this VM available because I'm running this on a 32-bit machine. So that's at least one way for just to be able to test it initially.
Okay. And the only reason why we generate only a 64-bit is because I don't think we have many 32-bit machines ourselves, and when we compile the thing,
They're on the way out, but there's still many of us running older hardware.
okay, we could quite easily generate a 32-byte version. Yes, yes. This runs directly, you don't have anything to do, no coding, just running and follows the instruction in the user guide. That would be.
And if anyone's interested in just literally looking at the command line stuff, it's very simple, but I can show you this on the laptop.
Yeah, I had trouble getting it running on some specific Linux 64-bit
Yeah, remember.
systems actually, so it's not running on all Linux systems just out of the box. So
Yes, actually, I've noticed that there are some problems with the Perl archive system.
exactly.
So maybe on some platform it will be problematic on the first run. You have to delete the temp folder called lab something. Then we run it.
Which version did you use?
I think I had problems on Census 5, which is not a really new one, so maybe on...
No, I've run on CentOS, well, a version of 5 and a version of 6.
Yeah.
So, but it's only Red Hat or Ubuntu and that, but we didn't verify that. So. Did you try Ubuntu as well, or?
No, but I think it ran just out of the box on Census 6.
Okay, 6 solution.
So maybe you have some issues, but yeah, it's one of the problems with the Perl archive is that apparently there's some glitches. So
I'm not sure how much is that, but right now, he's going to do both the ARC files, raw files for each calls or units. But this one particularly might be servicing multiple calls at the same time. Is there some facility so that these clients belong to that writer? Or?
no, as we were saying before, not yet, but you've suggested that we add this into the writer, and I think it's a good idea. So the whole point was the writer should be able to control more things about what it is writing and where. So maybe adding web interface to the writer with some controls on. One thing that you can do with the proxy is you can add like some prefixed HTTP headers to the requests with a lap slash in front. Those will not be sent to the end server, but will be intercepted by the lap and will be added in a special field in the metadata object that you receive in your writer, in the Java code in that case. And so you can use that to take a decision on where to write it. So then the whole thing that we need to add is just a piece of code to make sense of that additional header and do something with it, and maybe have a web interface to configure that. But I think it would be pretty easy to do.
I think it would be very, if it fits a little better with the current workflows, if I can be sure, like, for this call here on my files, I don't have to like mix and match, or I have to run multiple proxies just to be able to do concurrent calls. Makes a lot of sense.
Then again, running the proxy is pretty easy, so you can run many if you want to. It's just one binary file to
Sorry if you already covered this, but do you want to talk a little bit about sort of where you're at with the project in terms of the collaboration piece and some other IPC members are going to kind of test and evaluate?
So we had 4 members helping to test. We have 2 tests that have come back, waiting for 2 others. And so I'm compiling the feedbacks, which are 1 or 2 pages feedback. And what I've done today is sum up what I've seen. And I will do a write-up of all the feedbacks, send them to you, or you, depending on how we switch for up. And then we'll be done. The other thing, as you mentioned, is we need to put the lab code itself, the core code, on GitHub and share it with you. And then I think we will have done our part. There will be some additional work on implementing some of the feature requests that we've decided to implement. And I'm not sure how we will do for the feature requests that regard the writer, but this can be outside of the project, maybe a second part of the project, maybe. So right now, for the development part, all we need to add is HTTPS, I think. The rest is covered, I think. So I think we'll be really pretty short.
Is there any of the feedback you've got so far, anything of particular interest to share in terms of what they were testing? Something worked that surprised you, or something didn't work that you thought should?
I noticed that some people were expecting, I think, the lab itself to solve some problems that actually call problems. The first idea of people when you give them a new tool is, oh, I'm going to test to archive that site that I cannot archive right now.
Yeah.
But the problem is always the core behind the lab. The lab is just one piece of the crawler actually that is externalized, but still a piece of the crawler. You still need to have the part doing the right request to archive the right resources. And I think that's one of the main things I've noticed, is that it's not solving everything at one time. It's just one piece of the solution. You still need to develop specific writers.
And also for playback as well. I mean, there are still issues where you can capture the content, but you can't play it back because there are randomized things in the links for the players.
Exactly. Yeah, maybe we'll be able to experience this when we are replaying the.
One of the things we need to look at maybe from the wayback point of view is we don't use wayback, so we don't have very little knowledge on what I've just done. But I mean, for example, there was a couple of sites where I was able to watch Flash videos, for example, and I found a sort of bit where the wayback couldn't find the home page. It showed all the files related to that domain, and in that domain you could find all the Flash videos. But there'd be no other way of getting to them unless you could somehow data mine it. Then maybe there's something else that could make that work. I don't know.
So one piece of the problem is consultation. So maybe this can be solved in evolution of wayback. part of the problem is that some requests that are being sent out of the page at consultation cannot be modified, so you need to modify them on the fly. A solution is proxy-based consultation, maybe a plugin. I know Chrome is able to do that, like forging the URLs on the fly when they are being sent out. I don't think it's possible with Firefox right now, but Chrome can do that. So there are solutions, things to try, but it's true that one big piece of the problem is consultation, because even if you're able to capture everything that is being requested by a Flash app, for example, will not be able to be played correctly. So you have the archive, it's okay, but there are some more technical consultation. That's right.
Do those replay problems go away if you have a wayback machine, or the archive basically acts as a proxy? So
I think so, but we didn't test because we don't use.
We've been talking about this for a long, and I think that probably the only perfect, close to perfect playback where we're going to get it is if we can basically.
Yeah, well, with many modern sites, all URIs, all requests, AJAX stuff, it's all new URIs every time. So even though you manage to archive everything, you can only replay it if you can do really intelligent URL rewriting upon playback. So that will require a significant amount of.
Alternative way of doing it is to basically to mine, data mine the links and then associate that back with the page. And one of the things we pursued at Uni was basically a separate media player which identifies content related to the page.
Yeah, there are two issues. I think that there's a request that cannot that are being sent cannot be forged, so you need a proxy or something to intercept them, and if they don't change, you can replay them. And then there is a problem of like on the fly generated URLs with timestamp, some URLs that change every time you consult, or URLs that contain maybe like X-way coordinates or where you clicked exactly. We have had that case. Those are pretty tricky, so we need maybe to have filters at consultation time that remove timestamps, coordinates, some parameters of the URLs. So it's either you do some like fancy specific stuff, or and I don't think you can do without. In some cases, specifically like when it's complex media resources, either you find some really smart trick that does everything, but I don't think there is one.
You might be able to go some of the way with some kind of intelligent fuzzy logic search into your index. So
yes.
I don't have this URI, but I have this one that's almost similar except of this timestamp or.
Exactly. So we wanted to try something like having another version of the URL where you try to normalize something like, for example, when there is a timestamp, just remove it and replace it with some placeholder and have an index with those things that we remove and see if we are able. We do actually at URL normalizing, like ordering the query parameters in alphabetical order, just in case there might be switched or something. There are many other tricks like removing session IDs automatically, so on and so forth. So there are many URL normalizing tricks that you can do to make sure that you will hit the right resource even if it's been requested with a different query. But there is no like generic trick that does everything, so you have to like add up strategies one on top of the other.
But those kind of logic should be pluggable modules for wayback that we should share in this community, right? So
yes,
we're all struggling with this.
Exactly, because once you have such tool to do the harvesting, those issues rise up on the consultation part, and you need to be able to solve them as well on this part. So it's like a mirror. If you solve it at archiving time, you need to be able to solve it at consultation, because if you have archiving, nobody can access it. You've done it to nobody. So that's what you set for YouTube videos. Sometimes you can harvest them, but nobody can see them, or you have to be able maybe to make wayback look in a particular folder, or be aware of the fact that there is a resource that has been requested by this page somewhere in the archive that looks like that, and maybe able to find it, or doing some meta mining somehow.
Should I stop the writer now? I'll stop the writer and then fire it.
I also brought up a page that I know is a bunch of Flash presentations, like not video playback, but interactive Flash.
Okay.
So I'm going to stop the writer.
The domain is S#. he's a graphics designer, so I know he's got all these functions.
So we'll see.
Use that as an example, if you like. Just gonna take a few minutes.
Okay. So we're now stopping the writer and take the generated works into Wayback and try to do some consultation of what we just had.
Just a quick remark about what Johan said. I am currently developing, I hope to be able, hopefully I should be able to demonstrate it tomorrow in the access working group, a prototype of an Elasticsearch plugin for Wayback. So basically now it indexes what's in the CDX files, but we could use it for that. That's actually a usage I didn't think of. That maybe just actually at the NF we have often the problem that the canonicalization we have at harvesting time is not necessarily the same we have in Wayback, simply because some URL patterns change and we don't find it out soon enough, so we end up with stuff in the archive that needs to be canonicalized differently on the replay side so we can access it. And well, either we find a way to have a very smart canonicalization with like on a per domain basis and maybe even different time frames cited, but that would be over performance-wise, so maybe having a kind of search engine with fuzzy logic, with fuzzy requests would work, and actually Elasticsearch is quite good at doing that. So that's interesting.
So you will be able to look for URLs by normalize URLs differently with Elasticsearch, or what is exactly the point? Like you have an index of the URLs that you can normalize differently at consultation time?
Possibly, or if that fails, or if it's not performing good enough, we could have fuzzy requests to try to find URLs that possibly could match.
We'll take a look afterwards. So now we're going to try to access what we archived. What was the website?
S and then SHARPE.com. Oh, there's two S's at the front.
Today?
Yeah. So the enter at the top should pop up. Hey! So like interactive top has some interactive.
Menu?
Yeah. I was doing the interactive ones, and there should be some.
Since you're not in proxy mode, we can't actually be absolutely sure that that's not a live web.
Oh, that's true. Yeah. Unless we tail the
let's look at the requests.
Yeah, well, never mind.
So how way back.
The Swift is coming from way out. Yeah, that's.
I think everything comes from you. Oh, looks pretty good to me.
I think those SWF files at the end are the most important ones.
Yeah.
Any other sites?
Any other?
It was
I've been browsing INA, INF, EL, Sandbox, whatever.
So INA. So you went on the INA website?
Yes.
Let's try it. And we will have the videos. Not sure. I don't think the ads come from the. I think the ads come from the live web. Check. Facebook is direct. Flash content, probably zero. Did you browse through particular categories or?
No, only, yeah, those arrows there on top of the front page.
Yeah.
I think that's not working because
No,
of
I don't think it works.
writing problems. It is archived.
You could watch if it's been archived. Is there a way back? Yes. Oh, yeah, because it's JavaScript generated URLs, maybe the same like consultation.
So there was the news.bbc.co.uk.
Okay.
UK.
Oh.
I looked at the explosion, I think it was.
This one? Alright, looks pretty good.
Let's try the video on NetReserve.
Oh yeah. Net, no, August. Downstairs. Oh,
I mean, the video is actually hosted on YouTube, but
let's watch the request because I suspect that YouTube is doing like HTTPS requests for the video. So let's make sure. Nah.
I'm actually supposed to click on it. That's an exercise left of rigor. That's a stupid homework.
So as you can see, the image here is requested by the Flash. So Wayback cannot forge that request. It goes through Wayback, so it's going to the web. Same thing goes for the cross domain, that XML file, but for the rest, this is the player.
That's a fun one. Transparent yellow pixel.
Where?
A big one. There's a URL called-
Transparent red, transparent yellow. Yeah. Well, you don't have it in Wayback. Actually, we have.
Oh yes.
Oh, that's the transparent yellow pixel.
Nice yellow zone there.
Yeah. So,
I was going to say, I think this is good too, because it kind of highlights what you mentioned before, how Lab is a component in the overall ecosystem. It can't solve all your problems by itself.
yes, exactly. So at some point, there need to be efforts made a new project, I think, on the harvesting side to have new crawlers that will be able to crawl those videos and maybe work on Wayback on consultation for on being able to replay those roles and then we have the catch and are hard to fix at consultation time. So maybe proxy-based or plugin-based consultation with Chrome for the moment would be areas to look at. Maybe new projects. So I think it's time to wrap up and we are going to eat. So if there are more questions, just to sum up, I think people can now come to us and ask us to use the app. I think that's the goal now. People start using it, start having issues with it, and we will try to help them solve those issues. And I think most importantly, start new projects for new roles that will use the app and make the archive more complete. That's it.
I have a question. How about integrating this tool into existing infrastructure? We use web curator tool, and our curator uses this tool to make roles, to make jobs, and we would like that this cross would be evident in this tool. Is it that we write another writer that update the web curator tool database, or how?
I'm not sure you understood. Like you harvest with your current
we harvest with web curator tool,
okay.
A tool from New Zealand.
Okay.
And this is a management tool. So our curator inserts jobs into it, and then heritage scrolls. And he used this for statistics and analyze.
Okay, so it analyzes the resources that are there or not there in the archive.
Yes.
So it generates a list of missing resources. Is that it?
Suppose so.
No, I think the question is that when they use Web Curator tool, all the collection is documented in the Web Curator tool. If you use the proxy, you will just get linked WARC files, for example. So if you want those WARC files to be present in your database, you have to write some code to pull out the statistics and put them into the database in the same structure as the Web Curator tool does. So yes, that you would do that as a post-processing when you kind of upload the WARC files to the Web Curator archive or whatever that's called. You would need to do some updating of your management.
Or you could wrap the writer class.
You could write a class and do it on the fly.
How about that we use proxy settings in Web Curator tool? Inside there is some settings, so Hedrix could go to proxy, and Hedrix then write box, and we could write a dummy writer, suppose.
To generate the URL list?
empty con.
Just the addresses, or what is it that you need actually from the?
No, we remove the responsibility of creating WARC.
Does it already. What are you getting out of the proxy? What's the proxy doing for you?
Interpret JavaScript.
No, that's not what it's doing.
No, the
The JavaScript is only because we are browsing through a browser here.
Yes.
Just the proxy.
Yes.
So yeah, one of the points was that the proxy does not do the work what the crawler is supposed to do. So you need a crawler that will interpret the JavaScript.
Yes, because I have a presentation model. We use the browser to interpret the JavaScript.
Yes.
So we could fetch resources and generate content from Twitter, for example. I was comparing how your product is similar to ours. So there is no interpretation. Understand?
Yes, it just does the writing for you, but you still need a browser or crawler to do the JavaScript interpretation in your case.
Thank you.
I think one big advantage is that, exactly as you said, you need to have different crawlers running to get different kinds of content. All your content can end up in the same WAR files. So you can have a Retrix crawl a media file streaming downloader service that will write into the same WAR files, even if it's a separate component. So
actually, I had feedback from Temp Memory Foundation who used manual QA on their own archive and generated automatically a request through the lab for resources that were missing. So they were going through the archive with the browser, and every request that was not hitting the archive was hitting the proxy. So they were archiving, filling the gaps automatically by browsing the archive manually. So that's one way to use it.
And in a sense, you could crawl your own archive, just not write
Work
files again.
Yeah.
It's a heritage be a spider, basically.
Exactly.
Yeah, that's one of the things we're hoping to do with it, is to get Heritrix to crawl proxy through the logs collection and route the things that are missing through lab in order to get them.
I think that's one of the leads that
Right.
makes sense.
It's something that's on my list to do. Because it's a different way of doing QA than the way we do it at the moment, and we'll probably catch things that we miss now.
Okay. Thank you, good. I could take maybe a moment to thank LiveArchive for the collaboration with us on this project, which happened really smoothly, really nicely, and it was a pleasure to work with you on this. I hope we do more projects with you, and maybe follow up on new writers, new projects around the lab. It's very nice. Thank you.